Hello, this is part 4 in the series of videos dealing with transformations. And in this one, I'm going through an example where we've been given a transform function and we're required to list the order of transformations that get us there. I just realized I wrote the word translations there, so I'll just change that now while I'm seeing it. So you can see here that I've been asked to, we've been given the function g of x equals negative outside of 2x plus 1 all cubed minus 3. And we're told that this is a transformation from the base or parent graph of f of x equals x cubed. Okay, good. And it says list the order of transformations. Now, just anecdotally, I suppose, not anecdotally, casually, I suppose, you can see there's a +1 here, so that's a translation. -3 is another translation. There's a minus here, that's another translation. So, reflection, and the 2 is a dilation, so we can sort of see what kind of values are there and what effect they would have to it. And you might be experienced enough to say, well, I can see this would be a translation of the inputs. This would be a translation of the outputs. This will be a left-hand translation. This will be a downwards translation. This will be a reflection. Oh, it's reflecting. Okay, that's going to reflect about the x-axis. So you can probably do that. But as we saw in the previous video, order does matter. That when we did transformations in this order, it got us this function. But when we did transformations in this order, it got us this function, which was, I haven't quite finished it here, have I? But this function, but it's a different function. So order does matter. So this is the way I'm going to describe it to you. It's not the only way, and if you're looking at different videos or the textbook or something else, you may find that they describe the process in a slightly different way. And if they do that, it doesn't mean that I'm wrong or they're wrong. It just means that there are a few different pathways to comfortably get there. But I'm only going to show you one because otherwise it gets confusing. So this is what I suggest you do. You look at the function and work on the inputs first. And the order in which to work on the inputs first are translations, then reflections, then dilations. Once you've built the function up on the inputs, then work on the outputs. And for that, go through dilations, reflections, translations. It almost spells the word dirt, doesn't it? So you can think of it as reverse dirt, then dirt for the two different parts there. Okay. Now, reminder that input means a transformation of x. So you're replacing x with a brand new value. And the output is a transformation of the whole function. So the entire thing gets the value gets applied to the whole function. And as I said here, it helps to view each step as building a new function on the way to the final function. Okay, so we're going to have a look at the input. And what we see here is we are kind of starting off with an x. And so number one, I'm going to look at translations first, and I can see that the input has had a 1 added to it. So we would say that's a vertical translation left, I'll use the number, 2 units. Oops, 1 unit, sorry. 1 unit. Okay, what else has happened to the input? Oh, the input has also been doubled. Okay, which means that there's also a dilation. Let me see now. Towards the y-axis of factor 1 on 2. Remember, we flip it, so 2 becomes a half. So it's a dilation towards the y-axis. It's a compression towards the y-axis of factor 1/2. Now, compression is a legitimate word to use, but I have been led to believe that in the TCE course, they want you to use the words translation, dilation, and reflection, not shifts and so on. Made a bit of a mistake here, sorry. You can just say it's a translation left 1 unit is enough, to be honest. But I should have put the word horizontal there, but I'll leave it as it is. Number 2 is the outputs. So I can see that I need to go dilation, reflection, and transformation. There are no dilations here because there's no value outside the bracket, but I can see that it has been made negative. So I have a reflection about the x-axis, and the second thing is a DRT, a translation of 3 units down. Okay, so the -3 means it's a down direction. So translation of 3 units down. Please don't put a translation of -3 units down, because then you're using sort of like a double negative there. So translation of 3 units down. And I'll just take those in slide 8 there, that rectangle there that's left. I'll just show you that it does work, in that my base function is x cubed, and I've got a translation left of 1 unit. So I'm replacing x with a translation left of 1 unit. So that's x plus 1 all cubed, replacing x with x plus 1. And then part B is a dilation towards the y-axis of factor 1/2. I replace x with 2x. So I've got 2x plus 1 all cubed. And then for my outputs, I've got a reflection about the x-axis. So that becomes negative 2x plus 1 all cubed. That's the new function. And then a translation of 3 units down. So it's negative 2x plus 1 all cubed minus 3, because the whole of the function has been had minus 3 applied to it. So you can see I did get there. And one last thing I'll show you, and then that'll probably do us for this video. And then you really should do a lot of practice of this kind of stuff, really. The theory is the hardest thing, though. Wrapping your head around how these transformations really do build up new functions and stuff is just, yeah, it's tricky. So if you're finding it a little bit tricky, trust me, just lots of practice will get you there in the end, and keep on referring back to this theory. Let's just say I change the order. So let's just say I do B, then A, and then I do B, then A for both of the inputs and the outputs. So I start off with my parent graph of x cubed, and then I'm going to apply part 1b, which is dilation towards the y-axis of a factor of 1/2. So that would be 2x all cubed. Then I'm going to do a translation left 1 unit. Remember, every single step, what we're doing is we are replacing x with its translation. Okay, I'm replacing x with its, well, transformation, I should say. So instead of x, I went to 2x. So now the same idea. Instead of x, I do x plus 1. So it'll be 2x plus 1 all cubed. And that is equal to 2x plus 2 all cubed. So can you see how that makes a difference? Okay, so that's my transformations of the input. Let's have a look at the transformations of the output. So reflection about the x-axis. So that's just a negative to the entire thing. Oh, sorry, I'm doing it in reverse, aren't I? Translation of 3 units down, which means that the whole function, which is 2x plus 2 all cubed, now has 3 taken away from it. Then reflected about the x-axis. So that means negative the whole function. The whole function is 2x plus 2 all cubed minus 3. So it's negative that, which equals negative 2x plus 2 all cubed plus 3. So in fact, we'll end up going upwards by 3 instead of downwards by 3, okay, because we've reflected it. So we've got 2 key differences to what the function should be. Number one, instead of translating by 1 unit, I translate by 2 units, because effectively I've dilated the shift as well as the original value of x. And number two, because I've reflected the translation as well, I end up with a plus 3 instead of a minus 3. So 2 key differences there between the original, the function we were aiming for, which is g of x in the top left-hand corner there, and what we have actually ended up with here because of the order that we applied them. Okay, so hopefully that makes sense. So to summarize, what I've tried to do is I've tried to spell out really clearly what the kind of transformations are and why order matters. Okay. In terms of applying it, if you've been given a list of transformations, you just apply them, thinking about creating a new function every single time. If it's a transformation that affects the input, you replace x with a new expression, or like here, x goes to x plus 2. If it affects the output, then you apply the transformation to the entire function. So, for example, that now becomes equal to that. Okay. If you've been given a transformation, then the best way to order your transformations would be to start listing the transformations of your inputs, and then secondly, list the transformations of your outputs. Hope that makes sense.